As you already see, that he is very interactive with students. So you already know. So he is a great teacher. I'm very happy to introduce, formally introduce. He probably doesn't need an introduction. My good friend Raghu. Raghu Murtugudde is essentially an engineer, but he did his PhD in mechanical engineering, but worked on ocean modeling. So he became quite famous with his ocean model and stuff. Everybody started collaborating with him. Ocean model chahiye humko is karna hai. This is how he became got into climate. Then now he, of course, he worked with University of Maryland. He was a professor at University of Maryland, then associated with the big center on that science. Then he's basically now has become an earth system scientist. And he works on various aspects of earth system modeling, earth system variability, and so on and so forth, climate change impacts and so on. But I think he is lately associated with IIT Mumbai, IIT. He has been a professor there for 3 years. Just recently, officially retired. He will probably never be retired. I think Raghu is, as a scientist, I have been always impressed with his quality of work, but more impressed with his communication. He is a great communicator, and his interest is also climate education. So he writes a lot about for wider audience how to communicate the impact of climate or ideas of climate and so on. So it is, I think, and he's a great teacher, as I said. So, and when he says he likes to know everybody, and that is why he's trying to know everybody in this class. Okay. So I think he is very well connected to students, and so I'm sure you'll enjoy his talk.
Thank you.
Floor is yours.
Okay, so we will use this as part of the education now. So you have been learning about Earth system, the models, and some about AI already. Is this 3-week course or 2 weeks? 2 weeks. So you will learn more about AI. And you have learned about how AI is helping to improve models, downscale, make predictions as well, and so on. So we'll come back to Earth system model in a minute. And the sense you got from what you heard so far is that Earth system, what is the difference between a climate model and an Earth system model? This terminology has evolved over time. Basically, when we add chemistry, carbon cycle, we started calling it Earth system. And we include human beings mostly as people who, create emissions, make policies, fisheries, agriculture, land use, and so on. But AI, you are at a time where AI is growing so fast and it's doing amazing things, and it will become a part of Earth system, I think, in a very different way. Not just the physical, biological, chemical system, geological system, but actually human beings, on how human beings actually make decisions. And AI already has produced one foundation model. You already learned what is a foundation model? Not yet. So basically, it's the idea that you train a model on one set of data, let's say, and then it can work in many other contexts. If you capture human behavior in Bengal, let's say that's the most interesting state in India in terms of crazy behaviors, then can you also apply it in Kerala? That would be a foundation model. So you can start by thinking about how human beings make decisions, starting with this itself, right? If you think about it now, I'm standing here instead of Joy Mervyn Montero, whose title was, I think, Spectrum of Climate Models. So I'll go a little bit away from that and start with AI, talk a little bit about how we behave, how we make decisions, and then come back to Earth system, and then we'll see maybe even communications with animals, birds, and so on. So why is Joy not here? Because even though he could have given it online, he said his daughter is sick, so he cannot make it. So if you give AI data, it might tell you whether Joy tends to do this more than once. So the AI is dangerous in that sense, right? But if you go behind that and think about the topic proposed by Adway, Roxy, and Shikha, and Roxy and Shikha are not here, which is also part of human decision, right? And they, after deciding the topic, they pick some lecturers. And I was not on the original list, so you were all excited to listen to Joy. And now you have to adjust, adapt, she's looking very depressed that Joy is not here. So she's trying to mitigate her depression a little bit somehow. And that's my responsibility to help, right? So Joy's name may have come up because Vishal knows him well. And Vishal may think that I'm a pain in the ass because it may not be based on any data. Somebody he believes, somebody he trusts may have told him this guy is a pain in the ass, right? Why is it important? Because in general, we make decisions with something, memory, data, our brain has ways of storing physical experiences into emotional responses and so on. And there are several biases that you can count. One is called confirmation bias. How many of you heard of confirmation bias? No? Yeah, what is confirmation bias?
Likely to notice something if an event happens that already aligns with what you have these things more likely to.
Right? So more briefly, we all tend to have beliefs, and if there is actual data that contradicts this belief, then we will tend to ignore the data because we want to hold on to our belief, right? So Vishal may never change his belief about me. So what is AI doing? So now we are using AI more and more. On this side, it says LLMs can now help us, help communities to diagnose climate impacts. So it's a query system, as you know, ChatGPT, etc. So people can, LLM can take the information from satellites, models, predictions, projections, mix it all up and create a database and can create this question answer system. And people can get answers without having to call Roxy, who is always there on TV to tell you what happened, right? So that is on one side. This is exciting, but so you have to just make sure that LLM is not having any bias. And already we know that LLM is mostly behaving like a man because the system has been built by men. So there are already some biases in it. And here it says, is ChatGPT causing delusion or merely holding up a mirror? Which means we are giving it information and it's giving it back to us. It's learning something and we are thinking, it'll become independent and go crazy and throw us out of our business and take over climate business, whatever, all kinds of imaginations are there. So this is a technology, it's a disruption. It can do a lot of good things, but it's like a cell phone. If you get a cell phone, you can use it to text while driving. So cell phone is very useful, but it will not solve stupidity, right? So it's up to you to use it intelligently. Same thing will happen here. So let's add a little bit more to this about how we think, how the brain gets primed to see patterns. And we are teaching AI also to see patterns, right? So I'll give you one example and you will see how you will begin to think and may even, let's see how it goes, okay? So let's first define a system and then come back to Earth system, but in the middle, we'll go through humans. Who can define a system? Okay. So this is actually an animation. I don't know if I can make it work. It's a GIF. Basically, the changes color shows the blood circulation system and so on. A system basically is something that is made up of multiple components. And each component doesn't necessarily do something by itself. If you chop off my hand, it'll be useless. But when it is attached here, I can use it to make gestures and convey ideas and so on. And it's also working with my brain because I'm talking and my hand is coordinating my speech together. And if I feel thirsty, my brain will tell me to use my hand. And it'll even tell me how much force to use because it sees that it's a cup and not a plastic bottle and so on. So many things happen. So components work together to do something that each component will not be able to do. That's basically, so our body is a system, digestive system, circulation system, muscular system, skeleton, etc. And it's never really in equilibrium because the old joke is, what is the difference between a dead cat and a live cat? Right? A cat may be blind, paralyzed, deaf, whatever, but as long as it's breathing, it's alive. Right? So if somebody says you're in equilibrium, that means probably you're dead. So as a live person, you will never be in equilibrium. Brain is thinking something, body is doing something if you are able to, and so on and so forth. Even if you are paralyzed, brain may be working, etc. So a system is something that is always in kind of a disequilibrium, which is important because Earth system is also always in a disequilibrium, and this is important to remember. Okay, so we'll come back to this picture later on, and this is a typical figure that is always used to say what the Earth system is. So we have the geosphere, the biosphere, and we have added the anthroposphere, and everybody is interacting with everybody, and then there are external forcings from the sun, of course, daily cycles, seasonal cycles, but also orbital cycles. Volcanoes are an external forcing because it takes out stuff that is buried and puts it into the atmosphere. Everybody knows what a forcing is, right? Can somebody define what a forcing is? IIT Kharagpur, actually asking AI people may not be very useful. Who are the climate people? Yeah. Huh? Something that drives. So when you finish PhD and go for interviews, they will ask questions and they will look for keywords, right? And they will also see whether you are coming on time or coming late, right? So keyword here, forcing is anything that perturbs the radiative balance at the top of the atmosphere. So that's what these things, brings energy and energy has to go out. This begins to affect the radiative balance. Fossil fuels, of course, we are burning and increasing greenhouse gases. And we have become a forcing as well because this is what we are doing. And also we are changing land use, albedo, etc., right? So we'll come back to this, but the main thing about a system is that it's full of feedbacks. When I said my brain is working, my hand is working, and I'm reaching, it just means there are multiple feedbacks that can be going on, and we'll easily be able to deal with them if the system is working properly. But then we'll see that there can be some emergent behaviors in a very complex system. Like when I get hungry, I might start going crazy. You know that ad about Snickers bar when Dhoni becomes a hero and acts funny. So that's the emergent behavior, right? So we all have, systems have emergent properties as well. Okay, so we are now a big part of the Earth system. And AI is doing a lot of things to capture the feedbacks, to improve each component, and try to capture our behavior. But so far, as I said, we are only going after land use, policies, our science, technology, etc., etc. So we'll come back to that. But let's go back to human behavior for a minute. So this is pre-AI kind of material, where there's been a debate going on always about whether climate change is real, whether it's exaggerated, and whether we should do something about it. Especially now the US is being very proactive about doing something about climate, right? Anybody tracking the politics? So there were always books. This one says, Red Hot Lies, How Global Warming Alarmists Use Threats, Fraud, and Deception to Keep You Misinformed. So considering you're attending this workshop and ICTS is not a very fun place to come to, it's middle of nowhere, you must be interested in, at some level, in climate science, right? How many of you believe in climate change? He's not believing. Why you don't believe in climate change? You're open to debate. So he's got some ideas already. Don't avoid him during lunch. You're just a fine, he's a mathematician, so obviously they want to debate things. So do you believe in these kind of headlines? Maybe, I hope not. So State of Fear was a book written by Michael Crichton, who also wrote about dinosaurs and emergency ER, shows like ER and so on. But there are also people on the climate change side who use extreme language. This says climate cover up the crusade to deny global warming. That's from our side. So when you start using words like crusade and war and so on, you are really being a little alarmist. And this is from our famous global warming scientist, NASA global warming alarmist, endorses book that calls for mass genocide. So Jim Hansen, quite vocal and famous, eco-fascist author who wrote that industrial civilization should be destroyed, has it right. So, and he wrote a book called Storms of My Grandchildren, which is great. Then he says the truth about the coming climate catastrophe and our last chance to save humanity. This is quite nonsense, right? He doesn't have any scientific basis to say these things. So he's gone way beyond science to say these things. So if we do this, then others can do that also. So if you offer one tunnel vision, you can get another tunnel vision. And this is a book, Our Dying Planet. Planet is not going to die, right? We might die. Planet has always been there and it'll always be there. So it's about us and what we do and how we choose things. So should Earth system model include human behavior, which determine our choices, and our choices always have unintended consequences, which we will talk a little bit about, but you know all of them. If you drink a lot late night, you will come late to the class this morning, right? So there is always unintended consequences. So this is a statement from Pigeon and Fishoff with a very nice paper. It says, unfortunately, people often have flawed intuitions regarding how well they communicate, typically exaggerating their success. This is very common among the scientists, who, especially those who are specialists in communication. In ordinary conversations, we don't, people receive feedback. They might say, you're bullshitting. But if I'm standing here and talking, you're listening to me and not necessarily telling me that you don't like what I'm saying, right? You can say it, by the way, right? So here it says, without evidence to move them, science communication can lurch from one well-intended initiative to the next. A scientific approach to communicating science requires the systematic feedback provided by empirical evaluation. Will this happen? Well, maybe AI will begin to do that, but already many things are happening, right? So how will AI begin to help us in these things? So actually, I should have done this. All the animations got killed on this computer somehow, unfortunately. So the answers are given, but unfortunately, this basically killed the idea. I should have tested the PowerPoint beforehand. Yeah. So if you just, without looking at this, if you looked at this, the first one may have given you few ideas. Second one will begin to make your brain see some pattern. By third one, you will get angry saying, how can this guy show such obscene things here? It's not what I'm saying. It's your brain telling you that I'm doing something. But when you see the answer, you will see that what you think is all in your head. It's not necessarily what I'm saying. This is called priming of the brain. If you hear my name, you might think, this guy is weird, or he wears strange shirts, and so on, right? So we always have a lot of data associated with keywords. So that's called priming the brain, and our behavior, our exposure to stimulus begins to, release a lot of responses that are not really related to what's happening, and that's a good example, okay? And we are also very social in that sense that this is a kid. The parents have taught him that that football game he's watching, this is a Rotterdam, I don't know, you may know what this team is. So parents are lovers of this team, so they have given him the jersey and painted his face, and he has learned a few social behavioral habits to show his emotions, right? Match is starting today, right? Is it match? Yeah. So you will also be showing your emotions, maybe also skip the afternoon lecture or something. So we are very social in that sense, but there is a limitation. We have this behavior called us versus them. And a typical idea is that before, now we have cell phones, so we don't remember phone numbers anymore. But before, we used to remember phone numbers when there were only landlines. And the idea was that you remember about maybe X number of phone numbers, and those are the close ones to you. And if there is a cyclone or a flood and you have to save somebody, those are the people you will call first and not necessarily your neighbor or something. So there is that community structure that is very intrinsic to us, but it has a limitation. And that's very important because when you look at the work of people like Eleanor Ostrom, which is about how global commons or local commons can be saved, how many of you know what commons means? Commons are basically shared resources. Could be a pasture, could be a lake, could be the ocean, but there are scales, right? So her work showed very systematically that it's very easy to protect the commons with some rules and regulations within the community when the scale is small. But as the scales become larger and larger, this begins to fail. So climate change is basically now such a large scale problem that our intrinsic tribal mentality is not helping us very much because now it's a global common. Atmosphere is global, oceans are global. So we are now struggling with this. So how will AI help us with larger scales of commons? That's something you will have to think about. Okay. So you're learning a lot of things here, including convection and how to improve convection, diffusion, transport, AI, everything. But in 10 years, you'll be thinking probably, do I really need to do convection or will AI do it so I can work on something else? And what will that be? So you have to always now run with AI because it's moving so fast, right? So our behavior will also get affected by AI and so on. So how to bring this all together? Basically, we have one intrinsic processor that is called the rider and the elephant. Basically, it's called emotional elephant and rational rider. When you make a decision, there is an emotional aspect to it. Depending, how much money should I spend? How will it look if I wear this shirt or sari or whatever? And there is a rational part that is often about knowing the factors, but then either making a decision quickly or using rational ignorance or just saying wait and see. And global change brings all this in different groups. He's saying climate change is open to debate. You don't know what data he's basing that perception on, but others are convinced that climate change is happening, and it's also not clear. Welcome. It's also not clear how much you know, or you are just emotionally attached to that idea. That the media is giving you this sense that climate change is real and it's dangerous and it's risk and so on. And you can be rational and say, anyway, it's a risk, so I don't need to know the exact answer. If it's a risk, I will do something to reduce the risk. Right? So the idea is that big changes happen in your personal decisions or in a community level when the emotional elephant knows the path, knows what the outcome will be, and then the brain also agrees, then you move in that direction. The detail is that it's a big animal, it has large inertia. Once it's moving in a direction, it's hard to change direction. Right? So communities begin to go together in certain directions. US has gone in one direction, for example. India has gone in one direction as well. And these are big countries, big populations, a lot of money in the US, even if population is not big. So at individual scale to community scale to national and international stage, decisions are being made in this way. So AI will try to capture these and create what we can call foundation model. But knowing that Bengalis are very different than Mallus, how will we bring them together? Maybe these intrinsic behavioral aspects will be somehow captured by a foundation model. And then the question is, how do we integrate them into Earth system models? Two, because remember, climate change is great. Adaptation, mitigation, early warnings, disaster management, strategies for longer term, everything is great. But even if you produced a really perfect forecast, let's say, Texas flood happened and some more than 100 people died, which is a big number for a US disaster. In India, we wouldn't worry about 100 in general. But even if a perfect forecast was made, if there was no last mile decision making based on that forecast, it will not work. It's the same for adaptation, and it's even more difficult for adaptation because adaptation requires investments which have to be sustained, which means it has to be part of the budget, mainstream budget has to be set aside. It's not something you do once. It's an evolving risk, so you have to mainstream it into the budget, fiscal policies, and so on. So AI can come in there as well to help decision support. So AI is going to be a big part of this whole thing, including how decision makers even decide. We often overestimate the role of science in decision making, but maybe AI will be able to produce bite-sized information that makes sense for decision makers to make that decision. So there's a nice book called The Righteous Mind by Jonathan Haidt, where this concept comes up a lot. So you can read that. It basically tells you that we are all kind of hardwired to think in a certain way. You can say conservative and liberal, but basically contextually, we tend to lean towards one direction when we have to make a decision, right? So societal values, intrinsic values, and extrinsic. Intrinsic values are where you believe in a cause, could be environment, could be social justice, whatever, and you are able to fight for it. Whereas extrinsic value is where you buy a nice frame and a shirt and try to look cool. Okay, so extrinsic power also tends to chase power, politics, and Salman Khan, etc. Right? So now the animation worked. Okay, I don't know what's happening, but anyway. So coming back to climate, then how will we try to worry about behavioral issues in climate change risk perception? Let's say. So this everybody has seen already. Everybody, is there anybody who has never seen this? It's okay if you haven't seen it. You can come to the front. You don't have to sit in the back. There are seats here. Yeah. So this is the famous Keeling curve, which Charles David Keeling started in the 1950s because his smart advisor Roger Revell told him to start measuring. Has turned out to be one of the most iconic figures in our business. And you know that planet breathes, but there is an increasing trend and the rate of increase is accelerating and all those good things. But this is hardly, what's your name? Huh? Chittaranjan. Very nice name. Chittaranjan looks at this. It's a it's a well-mixed, long-lasting gas. So measurements can be very precise and accurate, reproducible. You believe that much? You believe this curve? Yes? Huh?
Yeah, like reliable, then we can believe.
Yeah. So you don't know that. You know that this is okay. So I mean, yeah, I'm not going to pick on you, but I'm interested in understanding the context of your skepticism. So this is a very good, clean, precise, accurate measurement. But the problem is when you take out the seasonal cycle and look at CO2, CO2 is obviously increasing monotonically rapidly, and you can average it over the hemisphere and gives you a good sense of the distribution or the hemispheric concentration. And then you put temperature anomalies on top, and that is not, it is going up, but not monotonically because there are intraannual variabilities, right? Ocean can hide the heat, glaciers can melt, evaporation can happen. So year to year temperatures don't necessarily keep going up like carbon dioxide, which is an inert gas. But if you do decadal averages, then you will see that with respect to a baseline, which is some, let's say 1850 to 1900, it doesn't matter, you can pick some baseline, it shifts a little. But basically we were cooler than the baseline before. In the 1930s, we started going up. Now, each decade is warmer than the previous decade. So whether you believe in climate change or not, this is scientific data which says that in the global mean, temperatures are going up decade to decade. Why is a decade important? Because this is not exactly climate. Year to year change is not exactly climate. You have to average a little bit longer. Anything longer, is, well, 10 years is a good enough average. Is this believable, Chitranjan? Yeah. So we are warming. You don't have to believe that, this is easy to use this to confuse people saying CO2 is increasing, but temperature is going up and down. So how do we know CO2 is causing this? There's a lot of science you can use to say, yes, it is. But does it really matter? If you average over the globe, nobody lives in a global mean temperature, global mean sea level. So Chitranjan can say, so what? What is happening in Kanpur? Is it related to this? And that's where the trick is. If you are experiencing something in your backyard that doesn't make you believe that global warming is doing something somewhere, then you still need to worry about human perception of risk. So the risk then works like this. This is, just a line from a famous guy called Rumsfeld, Donald Rumsfeld. He said, what we know that we know, what we know that we don't know, what we don't know that we know, what we don't know that we don't know. He just said it in a press conference, but actually he makes sense. There are many things we know, and there are also things we don't know, and we know that we don't know them, but there are many things we don't know. So we have to just be aware. But when you think about generally the risk perception, if you go from low to high, if you are a climate modeler or an AI person, you may know what your uncertainty levels are. You may have a good idea, but as you go towards people who are using this, let's say you are making an El Nino forecast and a bank is using it, bank will say El Nino is still, and there are real case studies of this. Bank will tell the fishermen El Nino in tropical Pacific, East Pacific, if El Nino comes, fisheries will be dead that season, that year. So the bank will tell him, no fisheries this year, you take a loan, you rebuild your net and your boat. And fishermen did that, and then El Nino didn't come. And in the meantime, the women at home are trying to manage life without the fishing income and so on. So when you are excited about doing AI forecast, you have to know how it gets used. The bank obviously understated the uncertainty in the El Nino forecast, and they do this routinely, right? So the perception of risk may depend on who you are, but if you are far from it, let's say you are a politician, you may say, nah, El Nino is not coming, don't worry. So you may blow up the uncertainty much more than it is. So in a real world, this can be called the valley of death. Whether you go from there to there or you just get trapped here depends on very contextual things. But AI may begin to take all these together, forecasts, users, perceptions, decisions, and begin to tell us how the value of death will work at various time scales. Weather forecast in India, we don't use it that much, but in mid-latitudes, people, the largest part of the news that is watched is weather forecast. People actually use it to make decisions on whether to wear high heels or skirts or take an umbrella or not. So it's a big part of the decision making, whether to go to a beach on the weekend. It's a $100 billion industry, right? In India, you don't, often you don't even carry an umbrella even in the monsoon, right? Because you think Ram Bharose, right? So this is very important because human beings' intrinsic ability to perceive risk is very complicated, and you can bring it directly back to climate change. Chittaranjan, maybe you have a car, you have a motorbike, you have insurance for it, you wear helmet. So he knows there is a risk, but what he does about it, right? So climate change, he wants to debate, and he's not seeing it necessarily as a risk he has to worry. Are you married? But you will get married. Okay. So you will have children. So you will buy insurance because somebody is underwriting your risk. You will save money for your children's education. Maybe even before you already started saving money for marriage, right? So it's not a joke. The way we think about risk, we are very happy to save money for kids' college. But if somebody says there is a risk that the environment will be very bad, air pollution will be very bad, they cannot even play outside, you will not pay for it. Why? Can anybody guess? Because it's a common. It's not your problem. You think somebody will pay for it. Government will pay for it. That is rational ignorance. That is the wait and see attitude. That is the rational rider. Emotional elephant may be saying his wife, you have a girlfriend, right? Yeah. So the girlfriend is believing in climate change or not? Huh? You have to ask her. So you should ask her because it will be interesting conversation. But make sure she still marries you. So women may think differently. She may think, no, we should make sure that the child gets clean air, etc. So our risk perception is very complicated. It's a time scale dependent phenomena and it's a scale dependent phenomena because commons, we cannot pay to save something that we think, even if I pay, nothing will happen, will be the easy answer. Everybody has to pay and I'll pay when everybody pays. So how will AI use these things to give decision makers bite-sized information to incentivize human beings to work towards risk perception? So climate change can be set aside and just pitched as a risk problem. And air pollution, in fact, kills more people than any disasters. The largest number of deaths in the world come from cardiovascular diseases, more than 30%. Natural hazards kill less than 1% of the total deaths. So we are not in the life-saving business. If you want to save lives, you go become a doctor. Okay, so it's good to remember that because a lot of people act like climate is killing everybody, but actually it's not. So risk has to be properly pitched as well. So the information we produce has to be relevant to make decision now or for the next 10 years. 2100, I'll come back to that later on. Projections for 2100. Who the hell is using this? Why are we wasting so much money on that? That's something you can decide. It has to be reduced complexity, so you cannot keep saying extremes are increasing because moisture is increasing 7%, 3%, all this nonsense. You have to just tell them what will happen and when. And it has to be timely so that you have to give the information at the time decision has to be made. Okay, so there's a terminology called post-normal science, what pitched by these guys. Basically, the system is complex, ambiguous, uncertain, but still you have to make decisions which are quite urgent. Okay, that tends to be called post-normal science, but also a lot of times you may do very high quality science, but it may not reduce the uncertainty in terms of decision making. Okay, So let's add sustainability, because whatever we do with the Earth system model, it has to serve adaptation, mitigation, as well as sustainability. And sustainability is a term that almost makes sense, but yet it's not clear how to implement it. So maybe AI will help there as well. So the Brundtland Conference adopted this in the 1980s, ability of one generation to exploit resources without jeopardizing the ability of future generations to exploit the same resources. Very nice statement, it's true, but what the hell do you do with it? How can you translate it into any kind of rules and regulations, requirements from people? It's not easy, right? It's very difficult. So, and then there are some optimistic views. Our species history is the progressive triumph of cooperation over conflict. Cooperation itself has seemed to have evolved over our need to hunt and gather together the big animals. You cannot do it on your own. So that needed cooperation. Plus, if you invented something very nice, like a nice fishing rod, and it works very well, somebody may look at you and steal the idea and do better than you. So if you cooperate and collaborate, maybe you will do better. Okay, but how does cooperation work? So this is an image from the Hawaiian island. The indigenous people, when somebody was caught catching more fish than their quota, this is what happened to the person. So this is how sustainability was ensured, right? And this happens to some extent in the real world. If you see somebody going and bombing another country which is building a nuclear something, then this is what is happening, right? So this is not just something that happened before. The world still works in a way. If you have a big danda, your bais will be yours, right? I'm a Saudi, so I can't pronounce things. Bais. कैसे बोलते हैं चित्तरंजन साहब? भैंस बोलते हैं. Okay. So these are also complicated issues. So we are now looking at all scales and human behaviors also at all scales. Imagine trying to do sustainable fisheries. A lot of international waters is out there, hard to police, even with satellites and so on. How do you manage fisheries? So very, very complicated issues. But there is hope. You can think of how many, everybody is a student here? Postdocs? Who are the postdocs? Chitranjan Saab is a postdoc. Only one postdoc. Two postdocs. And there are some undergrads. One, you just finished. Who's the undergrad? Maybe. Anyway, doesn't matter. So idea is, what would you do in the future? If you're thinking of Earth system and you're thinking of yourself as Earth system scientist, which is not something everybody likes. Goswami said, I'm an Earth system scientist, but Vishal says you cannot do everything. You have to do only one thing. So the perceptions can differ. So, but you can think of yourself as an Earth system doctor who will see what is wrong and maybe find solution, which sounds very idealistic, but honestly, using AI and models and behavioral aspects, maybe that's exactly what will happen. And it's called the second Copernican revolution by Hans Schellnhuber and the gang. Why? Because in the first Copernican revolution, remember we had a geocentric concept of the universe. We thought we are the center and everybody is going around. Telescope came, microscope came. Individuals sitting in labs were doing all the inventions, discoveries, and making money. Then satellites came, so we are going out and looking in. Copernicus told us that it's a heliocentric world and so on. So now we are going out, looking in, and we are working in bigger and bigger groups. Not always very useful, but IPCC is a group of some billion people. And when they put out reports, they are long. So ordinary people cannot understand them. So then they have priests who will explain to you what is in the text, in the scripture, IPCC scripture. And priests have power. They are allowing you to see God. So that's how these things can evolve. So you have to be clear about what system we are building when we build these large communities. So that's the second Copernican revolution. Work in big groups, but be sure what the mission is. And then you have to also worry about sustainability in a different way, where you are looking at something called Human Development Index, which is made. How many of you heard of this before? Yeah, so it's basically an index that uses per capita income, women's education, children's healthcare, various indices to say where you are. Higher the better, okay? And then you look at number of Earths, or you call it environmental footprint. And you can obviously see that poor countries are low on the Human Development Index. They're also low on the number of Earths they use, in the sense their environmental footprint is very small. But the rich countries have high HDI, but their environmental footprint is also large, right? So can you go from here to here without going up? Can you just do this? That's the Global Sustainable Development Quadrant. And it's not going exactly this way, because if you look at India and China, right? What is our carbon footprint per person? Anybody know? India's average is about 3 tons per person per year. China is about 7. Europe is somewhere around 7 also, but depends on how you count. US is 16 or so, right? But what is the trick? India 3 ton per person, rich guy will have 16 tons per person. A poor person will be living at a very meager level. And you are averaging the hell out of billion people and saying our average is 3 ton per person. So it's a meaningless number, but AI will begin to give you better patterns of how these things are working. Then you can identify the levers using which you can reduce overall environmental footprint while increasing HDI and so on. So AI will let you do that if we do the census and collect socio-economic data and all those things, right? So that's where AI will also help in terms of standardizing. Let's say we give everybody in the world 10 tons per person, and you fit whatever you want to do. You know, you take 2 flights, then you reduce your number of hamburgers or reduce driving. So you somehow manage your footprint to fit about 10 tons per person. That will be equitable. You can standardize, optimize. Pessimization is where you say nobody is going to follow any rule. There will be more and more presidents coming who will destroy all international agreements, or equitization, stabilization. And stabilization is where you just think of a guardrail kind of situation where you just make sure that we are not going off into some unsustainable, unlivable world, right? Remember, the planet is not going anywhere, biology is not going anywhere, it's only our own asses we have to worry about. So it's always about us. We are, of course, destroying many species, but there is something simple called nature makes the rules and biology finds the loopholes, which means biology always finds a way to survive. Will we also find a way to survive? Then the question is, who survives? Right? Even if we find a way to survive, who survives? Can we somehow make it equitable as well as stable? So all these are critical questions which will begin to get answered better and better with more and more data. Sorry? Different SSTs. SSP, this actually precedes SSPs. This is from a book that came out of a Dalam convention in 1998, first edition, 2004. So at that time, we were just starting the special reports on emission scenarios. And then came assessment. What was the next? RCP, no, between SRES and RCP, there was another one. Anyway, so it precedes the
the regional rivalry that is somewhat similar to optimization.
Yeah, so SSPs are going on the adaptation mitigation and the sustainability, and some vertical axis is, yeah, I forgot. But anyway, it's, yeah, anything you do normative thinking, this is called normative thinking because you are not just talking about physics rules, but You're talking about values. What values will humanity use to make collective decisions? And you will end up in a similar line, right? So either way. So we have a few minutes before coffee, right? And 30.
Because you're continuous.
2 hours?
2 hours. We can take a short break. Short break.
No, it's up. I can keep going, but I see that some people are sleeping already or they are doing SNS. I mean, let's ask some questions first. I'm speaking. There must be some questions. So let's take some questions and then you can stand up and stretch. Or coffee is available or
11. Yeah.
11?
Coffee will be.
Okay, so I can go till 11. The 9:30 to 11. My lecture ends at 11 or?
Yeah. I just checked it. I think you get 11:30, but we get 10.
My lecture is till when? 11. Okay, that's how I have planned it. I have only about 30 slides, but because I wanted more interactions, hopefully my pace is able, because these are not standard pedagogical lectures. This is supposed to make you think beyond a little bit. Hopefully that's possible. But are there any questions? You can. Sure. Yeah.
So you told that carbon footprint in India, there is a huge range, maybe from 7 to 16. Is it always like that, or it's evolved like in that way?
What do you think?
It's evolved in that way.
Middle class has grown. Chitranjan has a motorcycle. His father probably had a bicycle, right? So, all climate scientists have nice cars, nice houses, vacations. So it's obviously more recent. The top 10%, at least, the footprint has gone up very fast. A lot of poor people have stayed there. Poverty has reduced in India in many sense. Let's say when I was a kid, a lot of beggars would come during a day. Now nobody comes. Hopefully that means less starvation. But yeah, footprint, the spread has increased over time. Yeah.
Thank you, sir.
Sorry, you had a question? Yes.
Yeah, thanks for the lecture. My question is in general about how much of science that we do or technology is ultimately used by policymakers while they make decisions. If you could give us a bit more idea about that, and will AI help policymakers understand the scientific outcomes in a better way, and how scientists can help there?
Yeah, so there is a time lag in the science percolating into the policies and decisions, especially decisions. Because in India, for example, there may be many policies, but enforcement may be lacking. So climate impacts give it an urgency. So whenever you see governments seeking information, it means they are paying attention. What happens with it is another step. But AI will help to, the best way I can think of it is digital twins. So if a mayor of Mumbai can sit there and see an animation of very realistic animation of which street is getting flooded, which hospital needs to be evacuated, where sea level is being a problem, where he can build something or not build something. This will revolutionize decision making and integration of impacts on risks into decision making, I think. But there will be many other like health impacts, which more data you feed to AI, more no regret decisions will be made. Closing a school or stopping a train is a big decision, but telling kids not to play outside, old people to stay indoors is very easy decision, or wear a mask. So a lot of no regret decisions will happen with AI-based tools, which will come at hyperlocal resolutions. I think that's where impact will happen in policy and decisions. Yeah.
Just a small comment and question. Comment is that I think we'll appreciate the way you are exposing where the AI can come into this picture of decision making with respect to our climate change and variability and so on. So
They may not be able to hear you.
okay. Hello. So I think I have been here for now this week, colleague, and I have found that most of the lectures have not focused on how AI, because this is supposed to be the objective of this. And from the climate side, we had many lectures, but I have failed to see anybody sort of focusing on how it will help us. The application of this in terms of, first of all, in terms of maybe the improving the services, or in terms of adaptation mitigation and all those things, but in terms of also improving the science, for example, in whatever. So I think these are the things that we need to, I think I'm so very glad that you are doing in this in a very, very interesting way, and they're exposing the ambit where different, where this is going to be helpful. I think this is very important. I think for these students, I think it will be very, very
No,
helpful.
but they are still looking sad that Joy is not here. Any?
So my question is, I think that potential exists in all this. Now, my question is that even if the this AI is going to give us the suggestions for the solutions or things like that, so how we can solve this problem, the sustainability problem, unless we implement it. For example, this is not going to tell that okay, you have to stop using excessive energy. Energy consumption is shooting off the roof, and unless we stop that, sustainability is not going to happen. And therefore, it will probably suggest that. But unless we can stop these wars between between the countries, and they are going on demolishing and wasting all our energy, and then how it will help? So is it how that can be implemented? How so how is it? I think that problem is simply the solutions are not going to ultimately help us unless we can somehow force the implementation of this.
Sorry, I am expecting an important call. No, I will answer you in a second. Let me just attend. Sorry about that. Hello? 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 No signal. Okay. Anyway, I'm expecting a call from Partha, so not our part. Anyway, so military is a big problem. I'm working on that with some Chinese colleagues. We have talked about military's impact on emissions and land use, but not on the other aspect where militaries are now used to grab resources and defend resources or prevent sharing, rare earths, whatever. So it's a more complicated problem, but I will address the other sustainability part. Basically, there is, let's say, a bottom-up push from communities, scientists, or market forces, and there is a top-down push from regulators and so on. So somewhere they have to meet, and AI can make this possible. That's one thing. The other is this idea of reducing emissions has failed. 25 years of negotiations and CO2 is going up and up and up, right? So there is a paradigm called decarbonization, which sounds fancy, but actually that is the right way to think about it, in the sense not just net zero negative emissions, but you have to start decarbonizing the system. Systemic push. I said 10 tons per person, but can you really do it in this system? Right? So that is a top-down question. Systemic and interesting side point. This idea of personal carbon footprint, you know where it came from? Oil companies pushed it. They wanted to make people feel guilty and say it's not our fault, it's your fault. And it has worked because people worry a lot about personal carbon footprint. The point is you should not ever take your eyes off what the system needs, and system needs to decarbonize. Of course, we are the system as well, but that's where government actions will come. So implementation is very piecemeal, because remember, sustainability is a very local problem, but it has to adapt to global problem, global sustainability. Like resilience, it's very local, but global system is resilient only to the extent of how each little system is resilient. So they all have to connect scales up and down, right? So right now, biggest challenge is you can think of it as implementing sustainability, resilience, or decarbonizing. And there is a nice framework provided by one Per Becker, who the guy asked me whether I will use the Blackboard. Is it related to recording or something? Is this does recording get affected by? So the framework I would use is that you have the Human Development Index we used, if mentioned before, and you have environmental footprint we mentioned before, right? So you want everybody on the planet to have a certain minimum, sorry, I think it's in either way. There has to be a certain minimum human development index for everybody. And as a whole, we should have a maximum of environmental footprint, right? So we need some map on which we are working. And resilience is not going to be coming back to previous functionality, but adapting to the new reality so that your system also moves. So this kind of a framework can give, again, some foundation for working together because it's a scale thing. How do you go from a local village scale to the district level to state to nation to neighboring? Can India really be sustainable unless we are neighbors also? So I think you need optimistic vision. The future is yours, right? I'll be dead next year. So next workshop, I'm not coming, but you will be there for a long time. So you need to think broadly. And if you want to debate climate change, it's fine. But if you are going to have children, you have to worry about the risks. You can debate all you want, but what are the risks? If your children cannot breathe clean air, then what good is the money you make? So somewhere it has to work across scales.
Sir, you showed me the graph of CO2 versus the years. So there is a COVID time. So there should be a drop.
There is a dip there. Yeah, I didn't go into this one doesn't have it, but
Yeah.
this actually, when you do it carefully, intraannual, this one is smoothed it out with a 5-year running mean. But when you look at annual data with annual, there is a dip for the 2008 financial crisis for COVID. But the interesting thing is after COVID, it went up faster. Why? Because during COVID, the economy slowed down and countries put stimulus funds to reinvigorate the economies. How do we do it? We give people more money to spend. So our paradigm of economy is growth, right? So development versus growth. So Herman Daly has some points. I will mention that at the end. I'm not sure if I'm going at the right pace, but we'll keep going anyway. So we'll go for any other questions? So
Anyone else?
If I don't finish in the time given, we'll go to this Gillies bar near ISC and I'll give the talk there.
There is a question from the online audience. A long question.
Long question.
Before the industrial revolution, number of horses was high, and after the industrial revolution, with the introduction of vehicles, the number of horses reduced. In the same way, AI revolution is now happening. Now, to do humans' physical work, humanoid robots are going to come. To do human brains work, AI is there. So will this lead to real humans need eventually leading to human population reductions? Will that reflect the anthropogenic impact on climate change? Is this the indirect way of AI's help to reduce climate change?
What's the name of the person? Is it a PhD student or?
That I don't know. Balakrishnan is the name of the person.
Anyway, Balakrishnan. So I have written an article in Newsweek already 2 years ago on a population problem. So human robotoids, whatever he called, robots are not going to reduce human population. Human population is already reducing. China hit peak population. Many countries are now at below replacement rate.
Japan,
Right?
Korea.
Japan is a big example. And India is about to hit peak population as well. Fertility rates in India have dropped for almost 30 years now, right? So population is dropping independent of robots. Japan has tried to use robots to deal with the elderly care, babysitting, all that. So robots and AI will come in a more useful way, hopefully. But human population is dropping because the only effective contraception is that you educate girls. If you educate girls, they have fewer kids. And there is research about why rich educated women have fewer kids. Evolutionary biologists thought if woman has a lot of money, she will have more kids. And the research says that she wants to give each kid as much wealth as possible. So she will only have, let's say, 2 kids. But in the US, women said, if I want to have kids, I want to have at least 2 because that's better. But I cannot afford it, so I will not have any kids. So it's a complicated issue, but it comes down to women, which is a good thing because otherwise men will do stupid things, right? So in that sense, population will drop. And there is a nice book called Empty Planet you can read, which says by 2100 will be 1 billion. So the other part of this problem is reducing human population doesn't mean reducing emissions. If a woman wants to give more wealth to each child, that child will live well, consume more. So reducing emissions has not come with reducing population because rich people consume more even in India. Right? So we have to decouple this idea that population decreasing will also decrease emissions. Anyway, okay, so let's come back to the Earth system. That gives you a sense of all the human aspects of what we have to worry about, decision making and how we think.
When uncertainty is very low, you are naming that as
This
a
one. Huh?
no, the valley of death. Yes. So when uncertainty is low, then you are naming it a death. What is the reason behind it?
Why am I calling it value of
Okay,
death?
yes, yes.
No, value of death basically means this is a risk perception. The people who create the information have a better idea of what the risk level is, let's say in the prediction they are giving. But the user may understate the risk, and if that because they know how they can benefit from it, but people who are far away from it, they will think there is a lot of, like farmer may think IMD forecast is useless, but IMD knows where the uncertainty is. But crop insurance is saying uncertainty is not that high, you better take crop insurance. Crop insurance business in India is 20,000 crores per year. Okay, so value of death basically means the idea is probably died if you cannot get out of this and reach the people who are affected by your reduced sense of, or the portrayal of a reduced sense of risk, uncertainty, risk, whatever you want to call it. Okay, so this is used in a broader context as well, where the idea may die and never make it because of these miscalculation of risks.
Death of ideas.
Death of ideas, a lot of things. Okay, so let's move on because I'm going a little slow. So let's come back to the Earth system. So Earth system, you already heard the model. It has a lot of components. We'll look at that piping diagram again. But as I said before, system has the most important characteristic of a system is that it has feedbacks. Okay? And that means there will be unintended consequences because you do something here and you don't know how it cascades into the system through different components. One of the most prominent feedbacks in the system is called the ice albedo feedback. You know that Earth has had lots of ice ages throughout its history. And you all heard the concept of albedo by now? Is there somebody who doesn't understand albedo? It's okay if you don't, AI. You forgot. So albedo is basically reflectivity of sunlight, right? So snow is brighter than forest or desert, whatever. So it reflects more sunlight, which means it can cool the climate. So if somehow sun's radiation coming in changes because of the obliquity, precession, and ellipticity, and so on, then let's say at some higher latitudes, the energy coming in reduces, then it begins to build glaciers if the change is large enough. If the glacier grows, then it will reflect more sunlight, so it will get even colder. Then you can have further cooling till something breaks the cycle and you begin to retreat, which typically could be, again, the solar cycle, orbital forcing, right? So then if you start melting the glacier, albedo is reduced, more energy is kept by the system, not sent back to space because of reduced albedo. For warmer temperatures, more glaciers will melt. So you have this feedback, and now in fact you are having a very strong ice albedo feedback already in the Arctic. We have something called polar amplification. Arctic sea ice is melting and oceans are absorbing, Arctic Ocean absorbing more solar energy, and you are warming. So warming rate, I hope I have the figure. No, I don't have. So you can look up the global warming map and you will see that the warming is maximum over the Arctic, but also the deserts, Mediterranean and the Middle East, which there are other reasons. Nonetheless, the Arctic can be the Earth's air conditioner if we go into the cooling cycle, and it can become the hot house, which is where we are going right now, because we are melting sea ice and we are reducing the albedo and so on. So this is a positive feedback in either direction, right? So in the Earth system models, you don't have to put this feedback in, it's already there. It's an intrinsic property of the Earth system. So if you have sea ice and glaciers, land ice, it will do this, models are never perfect, but they are amazing because if you give it the energy coming at the top of the atmosphere, they do so many things, right? Monsoon, El Nino, weather, climate. So they are stunningly good, especially with AI. You will make them better and better. So there are intrinsic feedbacks, like if you deforest, it will change the carbon dynamics, carbon cycle. So it will have a feedback. Urbanization will affect albedo. More vehicles will affect greenhouse gases. So a lot of feedbacks are there. But there are many, you can call them emergent or not obvious feedbacks, which AI will begin to attract or begin to depict more and more. The more data it gets, even the output it can take from the model and interpret feedbacks that generally we don't necessarily interpret by using our hypothesis testing approach, where we are looking for certain feedback. And this is a nice example I always use. So they found that the pollinator population was affecting the vegetation in this coastal little forest. And they couldn't figure out what was happening till they did some detailed investigation. It turned out that some fishing activity started at the coast. People started catching fish. Those fish eat the larva of the dragonfly. But if you take out the fish, then the dragonfly larvae survive. Dragonfly population went up, and dragonflies eat the bees. So the bee population collapsed. Right? You can think of this as a feedback you didn't think of. It's an emergent property. So if you do one thing, it'll go in many directions and do something completely unexpected. And the more data we have from satellites, drones, this, that, and the other thing, AI will be able to grasp more and more feedbacks in the system, which means we'll be able to handle it better and better. The other question we have to, of course, keep always asking is how have things changed in the past, how fast they have changed, and what have been the impacts. So if you go back to about whatever million to the dinosaurs, so 65 million years or so, the scale is not linear. So temperatures were warmer. This is the high latitude temperature, Arctic, let's say, Greenland, 21 degrees C warmer than the present baseline. And we are worrying about a warming of 1.5 degrees, 1.2 degrees. We are saying 2 degrees means everybody will be dead and so on and so forth. So why do we have to worry about such little global warming if there's been so much warming before? Can you say quickly? Huh? Rate of warming? Okay. Aha, see, human beings were not there, right? So it's not about the planet, it's not about biology. Rate of warming matters, by the way, because some species will adapt, some will not be able to adapt. So if you think of a forest warming, under warming, the forest ecosystem will not move, but there are some mobile generalist species which can move to better climate up the mountain and so on. But some will die because they are sedentary specialists and so on. So the ecosystem will get fragmented, then its health, its resilience, complexity, productivity will drop as well. So that's why we have to worry about rate of warming as well as how much warming is happening, because it's a question of how much warming will we be able to survive. So is the rate of warming unprecedented? Some argument is that it is, because in the Paleocene, Eocene, which got wiped out here, there was a big pulse of warming and it happened very rapidly. We don't know exact causes yet, but it turns out that we may be warming faster now than even the Paleocene, Eocene thermal maximum. I don't know what else I said here. Biology always responds in very interesting ways. And I will give you one example of what AI will also begin to tell us. There are corals. You will hear a lot of people screaming saying corals are dying, but smart people will focus on where corals are not dying. In the Caribbean Sea, in the Red Sea, some corals are doing just fine because they are just changing the symbiont algae that, corals always live with algae. That's what gives them color. There are high temperature algae, there are low temperature algae. The corals are just throwing out the low temperature algae and taking high temperature algae and surviving. And people are sitting in the lab and saying, can we use those genes to transplant into the Great Barrier Reef where the corals are not doing so well, right? AI will help us with all this. The details are just stunning. Don't waste too much time about end of the world shit. That's not going to happen. Focus on what can be done, what solutions are possible. Okay? So be optimistic and keep focusing. Plus, biology also has done something interesting over time. If you look at the number of genera over time going from the Cambrian, 540 million years ago when there was an explosion of species, the biodiversity is basically increased continuously because after each mass extinction, there is a abundance of new niches that open up and new species grow to take that space. And this happens on very fast time scales during El Nino as well, where warm waters kill some species and open up new species. The system has evolved. So biodiversity loss, everything is true, but keep an eye on which species are doing well and exploiting the crisis for doing better. So you can see these are the variations in temperatures. There have been cold periods, glacial periods, warm periods, but continuous increase in biodiversity on long time scale has happened. So it's always about us. Biology and the planet will be fine. So the basic climate, you have already learned that we are trying to do energy balance, short wave coming in, long wave going out. And because we are on a sphere, we have a energy gradient. So deficit energy, excess energy, we are constantly trying to move energy, which is what gives us weather and climate. I'm saying it fast because you are already aware of this part. What are we doing? Basically, the energy transport needed depends on the equator to pole temperature gradient in some sense. And we are changing this gradient. Hence, it is going to project onto cyclones, ocean circulation, atmospheric circulation, precipitation, everything, right? So that's what we are trying to do. Coming back to global warming, this is what I was trying to point out before. The Arctic is warming very fast because, I mean, the answer is not just ice albedo feedback, but that is a big part. There is also water vapor cloud feedbacks and so on. And there are many complicated issues about why it's not warming here, why it's not warming here, what's happening here, why is there no strong ice albedo feedback here. And there is the Southern Ocean here, which is very different, etc., etc. So this is why Chittaranjan can say he can debate climate change, because when you looked at global mean temperatures, it is telling you that it's warming, which means the Earth system is trapping more energy. But how that warming is distributed, why is India remaining persistently less warming or even cooling? 2023-24 was a record warm year, but India had a cold anomaly. That's one question of science. AI may be able to help answer that. But the other is, just because we had a cold anomaly doesn't mean we didn't have extremes. We still have heat waves, floods, droughts, wildfires, right? So always remember, mean temperature anomalies on a longer time scale don't mean you also get reduced extremes. So it's a complicated problem, but we still have to resolve all those details, and AI will obviously help with that. And we are not trying to stop global change, right? Climate has always changed, as we said. Biodiversity has always responded, ecosystem responded. Our own species may have evolved because of climate change. This is in Eastern Africa, going from 5 south to 15 north. And here is age in millions of years. Somewhere around this period, the very green, lush forests of East Africa became dry savannas as it is now, less rain, and it's a semi-arid region, right? So the hypothesis, the best hypothesis maybe we have is that during this period, the ancestors, our closest ancestors, gorillas, etc., didn't have to run too far, walk too far. Food was available. Could hide in trees to avoid predators or fighting and so on and so forth. But when the forest changed, they had to walk faster or run faster and go farther to find food and so on. And believe it or not, when things run on 4 legs, they cannot run as fast as us, even though you think horses run fast. But humans can outrun a horse. After a while, the horse will not be able to run anymore. But human beings run 100-mile marathons and so on. So endurance is also an advantage. And plus, when you stand up, your spine is connected differently to the cranium, and we went from eating uncooked food to cooked food. So anyway, climate change may have played a big role in who we are now and why we are attending this workshop. Right? You're not convinced? Huh? What's your name? Uday. You're a PhD student. Huh? You're not debating climate change. You debate climate change? You believe in climate change? Because after a few days, Uday may not remember anything other than that I wore a funny shirt. So, furthermore, what AI will help us also will be the spatial scales. I won't go into this. Somebody may have already shown this. We have obviously, some people say we have more scales in the Earth system than in the universe itself and so on. All these processes, every leaf is moving. Do we really need to capture that to do the Earth system accurately? We don't know, but maybe AI will help us say exactly what leaves are doing, sorry. So you can see all the processes. Of course, one of the most interesting thing about, you always think about why life evolved here and not elsewhere. One thing that is underestimated is that our nutrient cycle actually involves geology. It's not, everybody says because we have water, but now the best news for you may not even be AI. In your lifetime, you will definitely hear that some microbes were found on the Titan or Europa or somewhere in the solar system. That will be more exciting than any AI Shai that you are doing. So life finds ways to survive. So we have to somehow merge life and Earth system together at all those scales. You already saw a lot of this, so I won't spend time. So everybody understands this, right? You already saw some version of it, how we do AGCMs, and then we go back to some history here. We have increased the complexity. Have we made the models more accurate? In many ways, but uncertainties remain nonetheless. So we started here with the atmosphere, land surface, the earliest one. Suki Manabe was making a lot of noise at that time. How many of you know who is Suki Manabe? What happened to him? Of course. The rest of you don't know? What about Suki Manabe? He was the first guy to make the GCM, but what happened more recently? He won the Nobel. Huh? He won the Nobel Prize. And the most interesting thing about him is he's even a little bit shorter than me. Okay? So he's a good friend for that reason. So anyway, we have added many things, aerosols, chemistry, upper atmosphere, it matters for various reasons. We're adding interactive vegetation and ice sheets. Interactive vegetation, so-called dynamic vegetation models, they are still doing some simple representations. But you know, those things compete with climate change. We said ecosystems don't move, species move. So species competition is still not there in these models. And we don't necessarily know so much about them either, but there is a lot of satellite data on vegetation, and AI will help us better understand how species are grabbing new niches as climate is changing up the mountain, across latitudes, across temperature gradients. And biodiversity, what determines it? It's a very interesting and very difficult question. If you think about oceans and corals, they are in the warm waters. For those who understand ocean biology, those are nutrient poor waters, but that's where corals grow, and they are very rich ecosystems because they are very good at recycling. They are the rainforests of the ocean. So biology is stunningly interesting. So people who spend too much time screaming about climate change miss very interesting things about biology. Okay, so this is coming back. What should we do to do the models? That's where the spectrum of climate models idea would have fit in. Do we need to worry about a model that captures everything, or can we still have reductionist models? Right? There is a scientific approach to this where you want to understand processes in any way you can. So if a simple model helps, good enough. Or maybe you have questions that need all these complications and the feedbacks. There are many, many interesting feedbacks that happen here. I won't go into the details. But there is the other question. If you want to provide useful information for policy or decision making, what do you need? It's a purely engineering approach. You don't care how complicated the model is. You don't care whether it's a dynamic model or an AI model. As long as you produce consistently useful, usable information for helping decisions, you will be solving a problem, right? Obviously, there is human exploration is a very interesting thing. So some people will want to do process-based studies or simple models, and some will want to go on the engineering side and just provide predictions, early warnings, etc., etc. So AI will help all of that. Even simple AI models will come along, which will help process understanding. Now there is a nice paper that came out, a review paper that says how deep learning can help process understanding. And everybody's GraphCast foundation model, there are a lot of models which want to do predictions because they want to make money. But there are a lot of people who are trying to use AI to do process understanding of Earth system, which means a lot of feedbacks. Plus, you want to translate the process understanding to predictions, predictive understanding and predictions. So it's a longer way, but will AI shorten the whole process? Maybe. So this was a nice paper that argued that if we wanted to build models to more oriented towards decision making, then we'll need a spectrum of models. So this is like a variable detail model, which, depending on whether you are solving for a drought or a flash flood or a flood or a wildfire, you may have quickly adaptable variable detail model, but usually you are worrying about resolution in time and space, of course, and time scale, whether you want to do 1 minute rainfall forecast or 15-minute cyclone forecast and so on. Number of processes. If you are doing just a cyclone, how many processes do you really need to give life-saving information, right? Process resolution. What complexity do you really need, as I said before? Dynamic coupling. Do you really need to worry about land atmosphere coupling, ocean atmosphere coupling, vegetation, biogeochemistry, and replicates? I won't go into the detail, but you want to have some sense of uncertainty assessment, keeping in mind again, your user will interpret uncertainty in their own way. So valley of death and all that good things are there. So what happens if we keep increasing resolution? What do we really achieve what we want? So there is a school that argues that IPCC models are basically not going to be ever useful if they keep doing incremental increases in resolution. They've gone from about 500-kilometer resolution in the first assessment now to something like maybe 100 or 50 kilometers. A lot of, fancier diagrams or images, graphics, but does that give you more information? But even more than that, K-scale models, kilometer scale models will produce so much output that you will not be able to do simple analysis on them. You will still need AI to analyze the output. It will be petabytes of output pouring on your head. Okay, so AI will again come back to deal with models themselves. That's model diagnosis. Okay, so the other thing you want to worry about AI is risk perception and risk reduction. Risk management is what it's going to be about. You may already have heard that risk is a multiplier of hazard, vulnerability, and exposure. Now there is also response, because if there is a cyclone and the National Disaster Management Agency does very well, then they will reduce the number of deaths. Biggest thing in India is mortality has gone down tremendously from natural disasters, right? So this is, we worry about how science is used in decisions. NDMA keeps calling people to help with early warnings, right? So India has focused for good reasons on early warnings. So that's where AI will also help in the last mile. Even if you go to 1 kilometer scale model, you may need heat wave information or flood information at street level. A heat wave in Bengaluru will not affect everybody the same way, right? Which people will be happily sitting in their air-conditioned apartments or traveling in air-conditioned cars, whereas street vendor has to work on the street or take the bus and so on. So you will need hyperlocal information, which Suvimal probably mentioned. So you will go from case scale down to street scale, again using AI. Okay, so here vulnerability, intuitively it makes sense, depends on social protection, livelihood diversification, insurance, risk underwriting, what kind of house you live in, per capita income, exposure depends on whether you are in a coastal area or crowded area, hospital is close by, and so on. And I will give you one example. I was involved, hazard is where we have generally focusing on when we talk about Earth system models. But here is where all the socio-economics is. That's where AI will have the biggest impact. To go back to where I started, human decisions, this is where it will all matter, right? One paper we did at IIT Bombay, student called Vittal Bhatt, who is now faculty at IIT Dhanbad. It turned out that the hazards have increased in India, but vulnerability, socio-economic vulnerability to hydroclimatic hazards has decreased. Why? Because women who have even 4th, 5th, 6th, 7th degree education are much better at using early warnings to take decisions. And they are not big decisions, by the way. In the slums of Mumbai, where we work with NGOs, For them, flood is not water here. Flood is this much water because they have no space to put vegetables, grains, anything. So any water that comes in becomes a flood for them. So they have to plan to move things somehow, save them, and protect children and so on. So you educate girls, vulnerability goes down. If you know such things, you can systematically reduce vulnerability and exposure. Okay, so AI will again come in there. This is how, it's a good way to think about. This is the paper I mentioned about how we understand Earth system processes better with AI, deep learning. And I'm not distinguishing ML, DL from AI, but I think you already learned a little bit about it. If you don't, then you can listen to my podcasts on my YouTube channel. I've discussed this a little. I'm not an expert in AI, by the way. I'm a user, and that's how you can think of yourself. There is always an idea, why are you talking about AI if you're not an expert? Well, I drive a car, but I'm not an automobile engineer. So I will use AI. I need to know it, right? So that's how you can think. So what are we doing? The observed data is coming at very large volume, including model output and all the observation systems. It's coming at a very rapid speed, and it's changing very rapidly as well. And it's a variety of data. It's just not just temperature and winds. It's also, computer vision, bioacoustics, human data, everything is coming in. And you need to make sure that the data is quality controlled and reliable, because AI can also do a lot of hanky-panky if you're not careful. And you want to produce patterns and knowledge, small and digestible pieces, which is what will be very critical for it to actually help decision making. Okay? And it has to be real time in some areas which are critical, like flood management or wildfire or cyclones. And it may not be so critical for slower time processes like droughts, maybe. Integrated across disciplines. So you want to not only worry about floods, but what diseases will come out after the flood, right? So AI will help you do that for sure. Okay. All the guys who came late are also sleeping at 11 a.m. You're drinking out last night? Huh? What's your name? You. What's your name? Huh? Siddharth. You're a PhD student. In what? IIT? Pune? I know. Working with Roxy. Same institute. I know, institute. The previous boss is. Who is your advisor? Amitabh? Mitra. Okay. You're not enjoying this, or you're up late night? But why are you sleeping? You're not sleeping. Your head went like this 3 times. Anyway, I'm picking on you because we always come to these workshops and then we go drinking, which is fun. But how do you stay awake? That's where AI can help. It will come with a little watch. And I'm not kidding. For snoring, this works now. It senses that you are snoring and gives you a little trick and stops you from snoring. So AI will help you. Get a smartwatch. So confidence and robustness, which will feed back to the system. Okay, so Mahatma Gandhi said, if it took half the resources of the world to make England so rich, how many worlds would India need? This, he said, long in the 1920s, I think, because some reporter asked him, what kind of a system, economic system, do you imagine for India? Mandela said, I just want to feed the people and I don't care what it is called, socialism or capitalism. Gandhi talked about sustainability when it was not a publication-based idea. Now everything is to be publication, right? So people used to think this way, that there is the environment we have to worry about, economic growth and social things we have to worry about, and sustainability is a kind of an intersection. But Herman Daly, who was an amazing economist, I met him, he was at University of Maryland, nominated for Nobel Prize for some 10 times, but he didn't win, died recently. He always reminded people that environment is not separate, we are in the environment. The more we exploit it, the less space there will be for further growth. So he basically argued that we need to worry about economic development, not economic growth. If you go to 1950s, there was a guy called Victor Libo who was a retail salesman. He was the one who wrote a 5-page paper saying, if the only way to grow economies constantly is to build things that don't last, so people keep buying again and again. And this works, right? How many of you are buying iPhones every year? Nobody will admit, but there are always long lines when new iPhones come out. So his idea was that we should really think of environment as an umbrella within which we live. So he said, he wrote some very nice things. Since the human economy is a subsystem of a finite global ecosystem which does not grow, even though it does develop, it's clear that growth of the economy cannot be sustainable over long periods of time. Why am I saying that here? Because AI will again help you track waste. 6% of the emissions come from food waste, including India, Bangladesh, Nepal, Pakistan. How easy is it to reduce food waste, energy waste, and water waste? AI will help you do that as well at home, right? Sustainable development requires that harvest rates should be equal to the generation rates, which can work for some things like water. Waste emission rates should equal the natural assimilative capacities of the ecosystem into which wastes are emitted. Very hard to do without AI, but now AI can help track these things actually. Reduction rate of any non-renewable resource must not exceed the rate of substitution by a fully equivalent renewable resource. Everything we do now is convert things to junk that cannot be recycled, but that's not necessary. So let's ask some analytical questions before we close. Are there analytical analogs for the human-natural system interactions? This comes from the Dalem report as well. I like them because we don't think enough about them. We get obsessed with papers and publications and model building. So Usman is already worried about when the first paper will come, even though he's in PhD only for 3 months or 6 months, right? Every day is a stress. But Pooja is not at all worried. So you learn from her. So is the Earth life system a benign partnership? Are we a bacteria, symbiotic gut microbiome for Earth, or are we a virus causing cancer? This is a question that we must understand. Is it a chaotic system lurching from one temporary state of balance to another? In a longer sense, maybe AI will be able to help answer this question. It's not a trivial question. Is life a purely passive passenger? It's not, because all life forms pollute, right? There is no life form which doesn't pollute. Overall, life cycle sense, maybe they pollute less or more, but in general, we pollute. Or is Earth a super organism, Gaia? This you can reject. If you don't know what that is, don't worry about it. Is it that no homeostasis? I won't read all of them, but you can think about many normative questions, not just analytical questions. As for adaptation, everybody has to adapt. Batman, Catwoman. This guy is selling some nice, he places this here, you use it for 10 rupees, you can cross the street. This is a very nice, simple adaptation. This one is a video that I hope will work. What happened here? Here, does it work? Is the guy here, the attendant? If they can play this, this is a very nice one. All the animations got killed somehow. Okay, so this is a nice video, very simple one. I use it to show how adaptation is very empirical. Mitigation is a global problem. There is global leadership on it because you can always claim that you are doing renewables, wind and solar, and get a lot of attention. But adaptation is hyperlocal and it's very empirical. There are no first principles. You have to just keep learning from doing. And this one shows how the big elephant can easily cross, but this one does something fancy, just learns to cross. So does that mean only rich people will be able to adapt, or also poor people will be able to manage something? Is here? So these are the kind of issues we have to worry about. I don't know when he's coming. The other thing is this projection business. Now they have this next projection, CMIP 7, will actually do some decadal forecasting, which is very good, very useful. But they will still spend a lot of resources on projections. So as future generations, you have to decide whether we really need more projections. This has already given us a range, good targets, bad targets, business as usual. What use is there to doing this? If this is uncertainty that can already cover what Putin will do or what Trump will do, why do we need more projections? Can we just focus on decadal forecasts at higher and higher resolution and then use AI to produce information for each sector, agriculture, water, energy, health, transportation, buildings, etc. Right? So that's a tough question, but this is an elephant. Remember the elephant, once it starts moving, hard to steer. IPCC is an elephant, and it has a big support in Europe, and India also wants to do it. But maybe one good thing Trump will do is kill US participation in it. Right? So this is the carbon trap I was mentioning. The idea we have used so far is that we want to reduce emissions, so we try to protect global commons and produce public goods and distributions of emissions reductions through Paris Agreement, nationally determined contributions, and so on. But the political response has been in such that emissions are not reducing at all. So the other paradigm suggested is to go after decarbonization. Then you don't have to debate about how much warming is happening, etc. You decarbonize the whole system. So then it's a global fractal. Fractal, I think many of you know, self-similar systems. You keep going into smaller and smaller scales, it looks similar. So the system is right now basically a global carbon emission fractal. So disrupt the carbon lock-in and catalyze transformation at multiple levels. This is where AI will be really able to help in terms of technologies, not only for climate and models, but also, miniaturization, battery, materials. Three big things that will disrupt the business. Then it can be experimental, multi-level, multi-scale action to overcome the fractal carbon trap. So I see this as a top-down implementation versus bottom-up. So AI, to end on some optimistic note, AI is now decoding how animals communicate. We already know that whales call each other by names. Elephants are very intelligent, and this, imagine Earth system model will also have AI helping us talk to animals and birds and help them, be safe. We don't have to widely kill everything, right? So we can grow that way as well. And Chitranjan will buy a car when he gets married. You can't blame him. So when people say it's getting hot and more people will buy AC, you should say, so what? Let's make AC decarbonized. You cannot say use less AC. You just find a way. So Chitranjan may collect many cars because it's not just a transportation for him. He wants to actually save cars. Then let him, because you can just decarbonize it, right? So old people like me will ask, wait a second, okay? When will you make something that matters? And you will say, when will you make something cool, right? So now you can do both. You can do cool things that matter, make a lot of money, save lives, save the planet, and find a good girlfriend, right? Is that my last slide? Yeah, I think so. So let me see if we can play the video here. The video has. It's not playing. Maybe I can play from outside. Huh?
There's a video need a source file actually.
Source, it's a TPT file. Source, it's a GIF file. Source is there. It works on my computer. Something got.
Yeah, I think so.
Anyway, I'll share it later to Adway, and then he can. Just a little cute video of how adaptation happens. Anyway, we are close to tea time, so we can end here and take some more questions.
Yeah, more questions. So yeah, maybe more questions. First, I have my own questions. I'll come.
There.
Hi, sir. Very interesting talk. I hope you can hear me. So for a lot of problems you have posed, AI can help us. AI is a solution kind of thing. So my question is that your perspective of this AI can help us. Is it from like AI can see more things than us from what we already have, or do we need more data for AI to see things? In the sense that AI can help us. For AI to help us, do we need more and more data, or AI can help us with the data which we already have by seeing more things than us?
That you can answer yourself, because obviously you'll need more data. So the way we state things, you said AI can be the solution. I don't think I said solution. I kept saying, right? So how we paraphrase things matters, right? So obviously we'll need more and more data, but optimization is possible. You cannot keep spending money to collect all the data. AI will help you optimize the web of sensors. That's where AI will help. So let's say India wants to worry about bioterrorism. So they have n number of airports where, let's say, some friend from a neighboring country comes and releases something. So they will map which airports are the most likely entry points and how it can spread based on people's travel. It's called social computing, and there's a lot of good work on this. So you can use meteorology and AI, and meteorology and physical links and graph theory, AI, to say which airports need to be heavily monitored. So it's an optimization problem. It's not a blind collection problem. It's an optimal bang for the buck kind of problem, and that's where AI does the best job.
And just one more question to add on that. Is AI sustainable? There is a lot of debate on that. So what's your opinion on
Is
that?
AI sustainable?
Yeah.
That's up to you, right? AI is consuming more and more power, but so will you as you go richer. So each autonomous car is a cloud on a wheel. It's doing a lot of computing. It needs energy. If you decarbonize, then you don't need to worry, right? So it's, as I said, using more ACs will be necessary, which means goal should be to decarbonize AC. That's all. So if you need more data, you find ways to collect more.
Do you think that decarbonization at that scale is going to be feasible?
So this is where game changers have to come along. Scalable carbon capture is not there yet. It's a big problem. But I have an optimistic vision that solar and wind, for example, imagine you are going around with a shirt which has a little chip which can kill the microbes, cool you and heat you when as needed. You don't need any centralized utility scale systems. You do decentralized miniature scale energy production, which can capture your body heat. Now already there are machines which can capture energy from your knees as you're walking and so on. Obviously, there is a limitation as to how much you can do that. But the miniaturization, materials, technology, AI together, before I die, I might see many interesting things. Right? I think it's possible. Energy, see, it's always about the Kaya identity. Energy per GDP and carbon per energy. So if you reduce that and population drops, right? So
Sir, I have a very trivial question regarding the understanding and data reliability of Earth system models, since I'm not from that background. So let's take three scenarios per se: one paleoclimatic scenario, one present conditions, and one.
Can you come forward? Yeah.
Let, take
one is what?
Paleoclimatic conditions scenario, one is present condition, and one is future predictions per se. So when I'm getting the data from Earth system models for present conditions, I have observation data to validate. But what about scenarios of paleoclimatic or future predictions? Where do we validate this Earth system value? Is it the reproducibility of the data or output at different scenarios which ensures us the validity, or like?
So, I mean, we don't usually call paleoclimate as scenario, but it is, it's one of the main problems is you get local data. Some are globally representative, some are not. right? So it's a matter of how much data you have and how representative they are of global scale processes, like glacial, deglacial, if it's a snowball earth, how extensive was it? So there is a data problem, and then you're trying to use the models to fill the gaps to understand. So there, data can give you a hypothesis, then you can try to test the hypothesis, try to get more data, make a theory, so on. So it's traditional approach. Now, people will use all the existing data, put it into AI and see if AI can learn some patterns that we have missed. So you don't need to think about models as some standalone models anymore. So paleo data will continue to be gathered more and more, and we are also finding more ways of getting past data, right? So snails and caves and ice cores and sediments are always there, but there will be more ways of also producing more past data. But future is, main thing to remember is that the uncertainties for the next 10, 20 years are all related to models and internal variability. That's why when you look at the projections, all the models are basically close together, right? Where did this go? Where would I had the projection somewhere? This one. So they are all clubbed together for a couple of decades. So the scenarios don't matter so much here, right? But here, the uncertainties are entirely related to the scenarios. You can make up shit and RCP, SSP, whatever you call it. And question is, and the argument is that this gives you a sense of everything that happens, whether Putin invades Ukraine or Hamas and Gaza fight or Trump does something, nothing matters. This is the range. If this is the range, why do we need it more? Right? So because these are made up, if you read the scenarios, they are just all kind of scenarios. So future is uncertain. The question is, where is the decision horizon? Okay, so you have to, the models will do whatever you give it, and there's iteration between integrated assessment models, Earth system models, a lot of details. But basically, you are producing emissions for the future, assuming population, technology, electrification, energy sources, etc. So, yeah. Anyway, yeah.
Next. Yeah. Anyone else in the audience?
Thanks for the second part. My question is about these scenarios. Actually, integrated assessment models will have to back propagate that information to climate model, which will again forward give you some projections and so on. So here, how do you think machine learning can help?
Yeah. So I don't know how well you know the integrated. By the way, how many of you know what is integrated assessment model? Okay. Okay. So you know, they have, it's a socio-economic model. Let's say, a lot of times it's like an Excel sheet. Okay, I don't want to put them down, but they have something called that damage function, for example, which tries to translate temperature into impacts. This is a huge number where AI can definitely help. So that's one thing. But in general, when you are integrating multi-layer systems, right? So you have agriculture, 25% from agriculture, atmosphere takes up 25%, ocean takes up 25%. Something is missing in, when you do carbon calculations, something is going somewhere. Can AI close that loop? Can integrated assessment models do better with that? So AI is going to be helpful in more ways than we can imagine. But so we have to move fast to use that. So this assessment may not use much AI, but I don't even know why they do assessments anymore, but that's my personal pet peeve. Yeah, there is a lot of role. Yeah. Okay.
Okay, then let's thank.
Chittaranjan has
okay,
a question. Let's debate.
Yes, so it is like a debate kind of thing. So like when you like comment to protect the global commons, like you are trying to preserve the natural things, something like that. And when you are saying that about good life style, then you are referring to use as more resources as you can. So as one side you are trying to preserve the nature, other side you are trying to exploit the nature. So how this incompatibility is like going to affect or going to lead us to the bad results or predictions?
Yeah, so that's the question. Do we have to grow the economies by using natural resources in an unsustainable way? Or is there a way to use them sustainably? Right now, again, I love this no regret decision that can happen quickly, wasting food, deforesting, or polluting waters. A lot of things can be stopped almost immediately with good action. But there are some things which require, let's say you need wood. Can you do wood business sustainably? Or can you use microplastics to produce artificial wood, which is already happening? So it's the phase space of solutions is so large that we haven't used it effectively to reduce the impact, right? And what is the biggest impact? Number of people who are, everybody wants to grow in economy, and it's a good thing. You want to increase the standard of life as well as quality of living. Standard of life is consuming, quality of life is minimizing consumption, heading towards well-being. So you can always be pessimistic and say, nahi hone wala hai. But you can be optimistic and say, where are the levers? Right? So do you see a beer half full or what's the other one? Half empty. क्या पीते हो?
Sorry, I actually don't drink, but
पानी तो पीते हो ना?
yes, I full. Yes,
No,
I feel.
क्या पीते हो मतलब दारू
I
नहीं.
see like.
That's the problem is sustainability. Everybody thinks पीना मतलब दारू. पानी भी पीते हैं, वो भी वेस्ट मत करो. Anyway.
One last question from me. So you showed that large block diagram, which included among various human aspects, like the political or cultural aspects and all those things.
Yeah.
So I am a bit curious about how these things can actually be brought into an actual art system modeling. I mean, the huge block diagram which was there. Huh? Yes.
The Earth system diagram.
Yes. Yeah. So these institutions, political economy, or human population, culture, values, beliefs, these kinds of things, like what can be a good way of like incorporating them into an art system model? So like one thing which I personally am very fascinated by is agent-based models, which is like where you actually try to imitate the behavior of individuals at maybe at a very reduced levels. So, but I don't think many art system models as of now use agent-based models. So do you think it is feasible or it's a good idea to do that?
Well, that was my opening argument, right? That agent-based models are trying to represent populations with some density of agents, let's say. But I'm saying AI can now bring these to translate behavioral aspects to consumption and emission and biodiversity impact, everything. That's how I envision it, but I'm not an AI guy, so nobody will ask me. But agent-based models will be outdated very soon with AI if we
There
do
is
it.
something called agentic AI, where like basically it's like instead of considering, we can consider each individual in an agent-based model as an AI agent. That is the decisions which in current agent-based models, what the behaviors of the agents is very rudimentary. But if we have agentic AI, then they will behave more like human beings with the help of AI.
So that's the our thinking is to improve dynamic models with AI, but already people are saying let's just do physics with data and dynamical core and hybrid. So agent-based models are also taking a baby step towards putting AI into their framework. Instead, what if you just give data and let AI do the agents them itself, and then you can easily bring these things, right? That was my original point, that we have to think of bringing humans into the Earth system, which nobody is thinking, because we are still baby steps towards using AI. So it will happen, because even though he's sleeping, Vaibhav, what's your name? Siddharth. There's another Siddharth there as well, right? What's his name? Siddharth. Anika Arora's husband. Anyway, what's his name? Siddharth, right? Yeah. Okay, so, IITM Pune. Yeah, he's from there. Prabhu. So, just because a student is sleeping doesn't mean he's not paying attention. Maybe he's getting bored, saying, "What is this old guy talking about?" And he will go home and crack something. Right? That's what happens. No. Vishal is not paying attention to anything I'm saying, but he's doing better than what I'm saying already. Full of coffee.
Okay, let's thank the speaker, Setul. So today, after maybe in the later in the afternoon, maybe 4:15 or so, we will have another interaction session. So Raghu may join us for some discussion of some say possible research ideas which they can do in this. So you can float some research problems for them, and maybe we can also continue your debate with Chittaranjan.
Thanks a lot, Raghu.